Hi guys, welcome to Colossus mathematics class. Don't forget to subscribe, like and share this video. Thank you for always watching my video. I'm so grateful. Alright, today we want to look at the Leo hospital rule and its application. Alright, so we say let f of z and g of z be analytic in region R containing a point z naught. Then our f of z, if our f of z is equals to g of z and is equals to 0, but our g prime of z naught, that is when you differentiate your g, if it is not giving you 0, then the L'Hospital rule states that the limit of your f of z over g of z, if your g of z is 0, what you do is you differentiate your f and your g again. Now if your g of z, if your f prime and f prime of z is equals to, so here if f prime of z naught is equals to g prime of z naught and they are still equals to 0, what you do again is you now say the limit as z tends to what, to z naught, of f prime of z naught over g prime of what, z naught, will give you what, f prime prime of what, z naught over g prime prime of what, z naught. Do we get that now? Now if in case your f prime prime of z naught is equals to your g prime prime of z naught and they are still equals to what, 0, what you do again is you create another one. You see the limit as your z tending to what, to z naught of what, f prime prime of what, z naught over g prime prime of what, of z naught will be equals to the g prime 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 of, f prime 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 of what, of x over what, over g prime 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 of what, of x. I get it. So this simply means that if the limit, if you are getting the f of, when you differentiate first and you put your z naught, if it is 0, then you have to differentiate again. If you know, we are considering this g part, most especially we are considering this g, because immediately this g is 0, the equation will become what, undefined. I get what I'm saying, and that's what the hospital is trying to what, to eradicate from there. And that is why we have to what, to keep differentiating the value more and more until we are not able to get what, 0. So I'll be explaining some example right now that, which will explain what I'm trying to see by this Leo hospital rule. So the first example today is, evaluate. Let's say we want to evaluate the limit as z tends to I of z raised to power 10 plus 1 over z raised to power 6 plus 1. Now if you look at this example now, they say we should find the limit as my z tends to what, to I of z raised to power what, 10 plus 1. Now the first thing you do is you say let f of z be equals to z raised to power 10 plus I, comma, then let g of z, our g of z will be what, with this. Don't forget from our this, our up here is always f of z and our down here is always what, g of z. Are you get what I'm saying? So our g of z is going to what, z raised to power what, 6 plus what, I. Do we get that now? Alright, so the first thing we have to do is to find out what, our f of I. Now if you are finding our f of I, what are you going to do? Anywhere you see your z, you are putting what, I. So that simply means this is z, so I will have what, I raised to power what, 10 plus 1, comma, my g of z will be what, I raised to power what, 6 plus 1. Now look at this I. I'm going to apply the complex number. You know our I in complex analysis is minus 1. I get what I'm saying? That's our I squared. So I can, since this is 10, I can put it in the indical form to be what, I squared close bracket 5. 2 times 5 is what, 10, then plus 1. So what will this one be? I'm sure you should know what this will be then. This will be what, I raised to power what, I squared, then 3 plus 1. Do we get that now? So this, our I squared is what, minus 1 raised to power what, 5 plus 1, and our g of z is what, minus what, 1 raised to power what, 3 plus 1. Do we get that now? Alright, so minus 1 raised to the power 5 will still give us what? Minus 1 plus 1. And our g of z will be equal to what? Minus 1. Minus 1 raised to the power 3 is still what? Is still minus 1 plus 1. Do we get that now? And now this will give us what? 0. And this will also give us what? Our g of z will also be what? 0. Now you can see that here our f of z naught is equal to what? Our g of what? Z naught. And they are equal to what? 0. Now you can see from here that we now have to apply our L'Hospital function that says when my f of z naught is equal to my g of z naught and they are equal to what? 0. What do I have to do? What I have to do is simply say that the limit as z tends to what? As z tends to z naught of f of z over g of z is equal to what? F prime of z over what? G prime of z. Now what are you going to do? So now let's find our f prime of z. Our f prime of z means we are differentiating our f now. Now our f is what? Z raised to the power 10. So if you differentiate that, it will give you what? 10 z raised to the power what? 9. Now if you differentiate your g of z also, you will get what? Z raised to the power 6 plus 1. What will you get? You get 6z raised to the power what? 5. Now let's do that. So that will now be what? F of z, which is what? 10 z raised to the power 9 over what? 6z raised to the power what? 5. Are you getting what I'm saying now? So what would that give us? Now that will give us, what are we going to have here? We are going to have 10 over 6 z raised to the power 9 minus 5. You know, indices, division will turn to what? Minus. So this 5. Then that will become what? 10 over what? 10 over 6 z raised to the power what? 4. Are you know what I'm saying? Now that will be 10 over 6. Our z is what? I raised to the power what? 4, which we can also see as what? As I square 2. And don't forget our I square is what? Minus 1. So that's minus 1 square. And that's what? 10 over 6 multiplied by 1. And now 10 can cut 6 to be what? 5 over 3. So that means my final answer is what? 5 over 3. Now you might be wondering that, oh, why didn't I first put I here and check whether it will be 0? The reason why I didn't put I here directly is because I know for sure that 10 can divide 6. And if I, so since it's division I have, if I subtract these two, I'll be getting an even number, which when a complex number I is raised to an even number, you will most times get a positive number like what we have here. Do we understand now? All right, so let's move to the second example. So example 2 now. So let's say we want to evaluate. So let's say evaluate the limit as z tends to 0. Now look at this. Our z is tending to 0 of, let's say 1 minus cos z over z square. Now look at this example. Now the first thing you do is your f of z is equal to what? 1 minus what? Cos z. And what? Your g of z is equal to what? Z square. Are you getting what I'm saying? So now your z naught is your 0, like we know. So let's do f of 0 first. Our f of 0 was 1 minus cos 0 gz equals what? 0 square. You can see that automatically my g is what? 0. So my g of z, my g of 0 rather, my g of 0 is what? 0. And the condition is that my g of z naught must not be what? 0. Now let's take a look at this side. My 1 cos 0, if you punch your calculator, cos 0 will give what? 1. So my f of 0 is equal to what? 0. So now you can see that here your f of z naught, which is 0, is equal to what? Your g of z naught, and they are both equal to what? 0. So in this case where you are getting 0, what do you do next? you go further by saying the limit of f of z naught over g of z naught, as your z tends to what, z naught, should be equal to what, f prime of z naught over g prime of what, of z naught. Now let's take that one by one. So our f is 1 minus cos z, so our f is equal to 1 minus cos z. So this is our f of z. Now what do? Differentiate this. Now let's differentiate. If you differentiate this, one will become a constant, which is be 0. If you differentiate cos is what, minus sign. Minus times minus will give what, sine z. I got what I'm saying now. The second one, our g, let's differentiate our g. Our g is what, z square. So our g of z is equal to what, z square. Now let's differentiate our g. Our g is what, 2z. Now let's put 0, sine 0, which is our f prime of what, z naught, which is 0, sine 0, and g of z naught, which is still what, 0. Now you can see that my g again is still what, 0, and sine 0 is still what, is still 0. Don't forget, these are prime. This is not prime, these are the prime. So now you can see that your f prime of g, your f prime of x is equal to what, your g prime of x, and they are still equal to 0. So you don't stop again. What you have to do again is what, is to differentiate your what, your f of z, your f prime of z again. I get what I'm saying now. So now let's do that. So I'm sure we are getting what I'm saying. So don't forget to subscribe, like, and share this video. Now our f prime of z is equal to what? Okay, so the two of them are equal to 0. So in that case, what I will do now is that I will say the limit as z tends to what, to z naught, of f prime of z over g prime of z, let it also be equal to what, f prime prime of what, of z over the g prime prime of what, of z. Now look at our f prime of z. Now if you differentiate our f prime of z, which is our f prime prime of z, now if you differentiate this, what will sine give you? Sine will give you what, cos z. Do we get that now? Now let's differentiate our g prime now to be g prime prime of what, of z. If you differentiate that, what will it give you? It will give you what, 2, because if you differentiate 2z will give you what, 2. Do we get that now? Now the next thing to do is to put our constant, right? So our limit, which is what, 0. It's 0 we are given, so cos 0, which is what, 1. Now our g of 0, g prime prime of 0. What is our g prime prime of 0? There's nothing we want to put, so it is still what, it is still 2. Now you can now see that our final answer will now be what, because we have what, f prime prime of what, of z over what, over g prime prime of what, of z, as our limit z tends to what, to z naught of what, of f prime prime of what, of z, f prime prime. This is the third time, so that's what, 1 over what, 1 over 2. This one is over our g prime prime of z. So you can see that you have to differentiate this one 3 times before you are able to get an answer. So if for example, as I differentiated this one, it is still giving me 0, what I will do is I will still have to differentiate it again. I get what I'm saying? I will still have to what, to differentiate it again. So this is f prime prime, is the second derivative. So this is the first derivative, and this is the second derivative, where we get our answer. So let's change that. All right, so as you differentiate this one 2 times, so if it is another one, if it is still giving you 0 here, what you have to do is what, is to keep differentiating until you don't have 0 any longer. So I'll give you an assignment which I would love to see the answer in the comment section. So you can try this out. Let's say you have the limit as z tends to what, to 0, 1 minus cos z over sine z square. So you can go ahead and try this. Don't forget, this will be your f of x and this will be your what? Your g of x. And so you go through the same step and you'll be able to get everything the same way I get them. So thank you very much for watching. Don't forget to subscribe, like and share this video. Thank you.